we can see the properties of Fourier transform. After completing or studying this Fourier transform, the students can able to apply properties of Fourier transform and continuous time signal. Now we can see the first property, that is the linearity property. It states that a into x1 of t plus b into x2 of t equal to a into x1 of j omega plus b into x2 of j omega. Proof. Now we know that the that is the Laplace transform of this quantity equal to integral minus infinity to infinity, that is sorry, not Laplace transform, Fourier transform this quantity equal to integral minus infinity to infinity x of t into e power minus j omega t into dt. In the place of x of t, we are having a into x1 of t plus b into x2 of t. Therefore we are substituting that value, and here we are having two terms. Therefore we are splitting into it into 2 by taking the constant term outside. After splitting, we know that this term equal to x1 of j omega and this is equal to x2 of j omega. Therefore we have proved this linearity property. Second one is time scaling property, that is the statement if x of at is equal to, that is the Laplace transform of x of at is 1 by a into x of j omega by a. We want to prove like this. Therefore we know that the Fourier transform of x of at equal to integral of minus infinity infinity x of at into e power minus j omega t into dt. We are taking that at equal to tau, therefore t equal to tau by a, while we are differentiating dt equal to 1 by a into d tau. And also if t tends to minus infinity infinity, tau also tends to minus infinity to infinity. Therefore while we are applying in this condition, and here we are getting this value, that is we are just replacing this t by tau in all the places, and we are taking this constant and outside. Therefore from this we can write that this is term equal to x of j omega by a, thus proved. Time shifting property. Next one is, we want to prove that the Fourier transform of x of t minus t naught equal to e power minus j omega t naught into x of j omega. Therefore the Fourier transform of this quantity equal to integral of minus infinity to infinity x of t minus t naught into e power minus j omega t into dt. Now we want to change, that is for simplification, let us substitute t minus t naught equal to tau. Therefore from this we are finding the value of t. Here while t tends to minus infinity to infinity, tau also tends to minus infinity to infinity. Therefore we are changing all the limit in terms of tau, and after simplifying and splitting this term, we are taking the constant term outside from this out of this integral, and while we are writing this as here e power j minus j omega t naught into this can be written as x of j omega. Next one is frequency shift, that is e power j. We want to prove that the Fourier transform for this quantity equal to e power j at into x of t equal to x of j of omega minus a. Therefore the Fourier transform of this quantity equal to, as all we know that we are just writing by using this formula. Now we are combining this term by using, that is the exponential term of combined, by using the standard equation. We can write this as x of j into omega minus a. Time reversal property, x of minus t. Next one is time reversal property, that is x of minus t equal to x of minus j omega. Here the Fourier transform of x of minus t equal to integral minus infinity to infinity x of minus t into e power minus j omega dt. Here we are just substituting that minus t equal to tau, and all we are changing all in terms of tau, and while we are substituting we are getting these values. Here we can just adjust, we are adjusting according to this formula. Therefore we can write this as x of minus j omega. This is the quiz question. Thank you.